mathematical forms whose value cannot be determined. They are known as indeterminate. Okay. So here our aim is to study these indeterminate forms. 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, right? Then 0 raised to 0, 1 raised to infinity, and infinity raised to 0. These 7 indeterminate forms we have to study. Out of them, we define 0 by 0. Okay. What is 0 by 0 for? Suppose limit of f of x as x tends to a equal to 0 and the limit of g of x as x tends to a, both of them are equal to 0, then limit of f of x divided by g of x as x tends to a will be in 0 by 0. Right? Now to solve this we have to use errors, low figures. So rule is like this: limit x tends to a, f of x divided by g of x. If it is in 0 by 0 form, then that is if f of a equal to 0 and g of a equal to 0, then that is equal to f dash of a divided by g dash of a. Or in other words, if you want to write this in terms of limits, it will be limit x tends to a, f dash of x divided by g dash. Right, we studied up to this way. After this, we decided that 3 notes we have written. One, the rule is applicable directly. The rule of Aristotle is applicable for 0 by 0 and infinity by infinity for direct. So now what to do about these remaining 5 forms? We study. Okay. One. Second, we decided that we have to differentiate numerator and denominator separately. Okay. Third, whenever sin x, right, tan x, sin hyperbolic of x, tan hyperbolic of x, and their inverses, sin inverse x, tan inverse x, sin hyperbolic inverse x, tan hyperbolic inverse. If they are there in the denominator multiplication, that is multiplication of the remaining term, then we have to use the standard formula. And we have to remove them. Why to remove them and how to remove them? That we'll understand during the exam. Okay? Time will let me continue. We'll continue with the standard formula. That standard formula of the limits. Again, it is revision. Okay? They are very well known to you. So that's standard formulas of limit. One, limit x tends to 0, sin x by x. 1. Right. Limit x tends to 0, tan x by x equal to 1. Limit x tends to 0, cos x by x equal to 1. 4. Limit x tends to a, sin x divided by x equal to 1. Right. Next, fifth formula. Limit x tends to 0, hyperbolic. First sin hyperbolic of x divided by x equal to 1. Limit x tends to 0, tan hyperbolic of x divided by x equal to 1. Okay. 7. The formulas are valid for inversions. That is limit x tends to 0, sin inverse x divided by x equal to 1. Same for tan hyperbolic also. Limit x tends to 0, tan inverse x divided by x equal to 1. Limit x tends to 0, a raised to x minus 1 divided by x. Who remember the answer? Ninth formula. Who know the answer? 9th and 10th, you know the answer. You know the formulas? Absolutely. Log of a. And here log of E. Log of E is 1. Hope you know all these formulas very well. I studied them. Those who are online, have you studied all these formulas?
Yes, sir.
Yes, sir.
Visible now?
Yes, sir.
Sir,
Good. Yes.
limit x tends to 0, cos of x is equals to 1 is na?
Correct. Formula number 3.
Yes, sir.
Cos x divided by x equal to 1. No, no, everyone knows all these formulas. Remember? Okay. Have you studied this formula? Cos x by x equal to 1. Studied cos x by x equal to 1. No, formula is not like that. See, sin x by x is 1. Why it is 1? For that we can use the L'Hospital's rule. How? See, like this. L'Hospital's rule is applicable whenever we have 0 by 0. Let me cross check it. First understand and then. Suppose I substitute x equal to 0. What is sin of 0? 0, na? Right? And divided by x, and x is 0. So is it in 0 by 0 form? Yes. So I can use the L'Hospital's rule. How? I have to differentiate the given. What is the derivative of sin x cos x? What is the derivative of x? 1. Right? Now substitute x equal to 0. What is cos of 0? 1. 1 by 1 equal to 1. So all the formulas, formula number 1, 2, 5, 6, 7, 8, 9, 10 can be verified using L'Hospital's rule by finding the derivative. For example, say I find derivative of this. Let me write it. If I substitute x equal to 0, what is a raised to 0? 1. 1 minus 1 is 0, na? Numerator is 0. Denominator is x, but x is equal to 0. So we have 0 by 0 form. So can we use the L'Hospital's rule? Yes. Okay, let me use it. Limit x tends to 0. Derivative of numerator. What is derivative of a raised to x? A raised to x log of a divided by derivative of 1 is 0. Derivative of x is 1. Now substitute x equal to 0. A raised to 0 is 1. What will remain? Log a. And therefore answer is log a. Clear? All the formulas can be verified by L'Hospital's rule. Why? Since when we substitute the limit in these formulas, we are getting 0 by 0 form there, or maybe infinity by. I think 0 by 0 form in many of them. Now go through formula number 3. Okay. Now if I substitute x equal to 0 here, what is cos of 0? 1. Sin divided by x equal to 0. Is it in 0 by 0 form? No. It is equal to infinity. So cos x by x as x tends to 0, right? We have written 1, which is absolutely wrong. Remember this. Sin x by x as x tends to 0 is 1. Tan x by x as x tends to 0 is 1. But cos x by x as x tends to 0 is not equal to 1. In fact, it is equal to. Understood? Okay. Now go through the next formula. Right? Here, limit is changed. X tends to a. Let me substitute x equal to. What will get? Sin a by a. But is it equal to 1? No. Is it equal to 0 by 0? No. Like that? So this formula is also wrong. Limit should be x tends to 0. Then only it is equal to 1. Okay? So write formula number 3 and 4 wrong. Whatever formulas we have written, that is wrong. And we have written like this. Right, formula number 3 and 4 is wrong. It is not in this form. Getting everyone? Understood? Okay, let me continue. Start with different examples. Right now, type number 1. examples of type number 1. 1 minute. Write examples of type number 1. Examples of type number 1. Right? So 0 by 0 form. In front of it, 0 by 0 form. Right? Evaluate following limits. Evaluate following limits. X square plus 2 cos x minus 2 divided by x sin x. Done. Solution. Let L equal to limit x tends to 0 x tends to x square plus 2 cos x minus 2 divided by x. Acha, can anyone tell me what will be the first step? What will be the first? 3 notes we have written. What was the first? L Hospital's rule is applicable for 0 by 0 and infinity by infinity. First. Second, what we have written? We have to, whenever we have to use the rule, we have to differentiate the numerator and denominator separately. We don't have to use the u by v. Okay. Third note, whenever a denominator contains sin x, tan x term, what we have to do? We have to remove them using the standard formula. Standard formula is known to us. What is the standard formula? Limit x tends to 0, sin x by x is 1. Right? So let me remove this sin x. So sin x divided by x, and whenever I am dividing, I have to multiply by x. Okay. Now what is sin x by x? 1. So it is like this. Limit x tends to 0, x square plus 2 cos x minus 2 divided by x. Understood? Now understand one more thing. See, in denominator we have x square. Right? So to get constant, how many times you have to differentiate x square? See, first derivative of x square is 2x. What is the second derivative? 2. Right? So we have to differentiate twice. That is, we have to use the Hospital's rule twice. Understood? Now see, differentiating x square twice is simple as compared to differentiating x sin x. Right? So what will be the first derivative? X cos x, we have to use the product rule, sin x. And then again we have to differentiate this. And here we get 3 different terms plus, okay, 3 different terms. That will make problem more difficult. Getting everyone? Therefore, we remove this sin x. Understood why we removed sin x? By dividing by x and multiplying by x. So that remaining calculations will be simplified. Differentiating x square is simple as compared to differentiating x sin x. Therefore, we converted x sin x into x square by the standard formulas. Clear? Okay. Now write this step. Write this step. Doubt? Okay. Now substitute x equal to 0. Cos of 0, x equal to 0. Cos of 0 is 1. So 0 plus 2 minus 2, 0. Okay, divided by x, 0. 0 by 0 form. Right, using yes, use the rule. Derivative of x square 2x plus 2 derivative of cos x is minus of sin x, derivative of 2 is 0 divided by 2x. Again substitute x equal to 0, 0 minus 0 is 0 divided by 0. Right. Use the rule once again. Differentiate numerator. Substitute x equal to 0. Zero divided by 0. Understood? Next. Next example. Question is same, I evaluate the limit. Right. Limit x tends to half, it is not 0. Cos square pi x divided by e raised to 2x minus 2xe. It is not e raised to x. 2xe. Yes, solve this. Solution. Do it yourself. Try it yourself. Be like this. Let n equal to. Okay, now substitute x equal to half. So cos of pi by 2, 0 na? Cos of pi by 2 is 0. E raised to half, so it will become e. 2 will cancel. Right, and x equal to half, so 2 will cancel, minus e. E minus e equal to 0. Mention 0 by 0. Getting the answer? Then using derivative 2 cos pi x. Derivative of cos is minus sin pi x. Derivative of pi x is pi divided by derivative of e raised to 2x, 2 e raised to x minus derivative of 2xe. Derivative is what? 2e. This thing last. Okay, now here for this term, what is 2 cos theta sin theta? Right. Sin 2 theta formula. Using 2 cos theta sin theta equal to sin of 2 theta. So use this formula. So it is limit x tends to a half minus pi sin of 2 theta. Theta is pi x. Sin of 2 pi x divided by 2 e raised to 2x minus 2e. Okay? Now substitute x equal to 0 and see what you are getting. Substitute x equal to 0. Sorry, x equal to half. X equal to half, so 2 will cancel, sin of pi. What is sin of pi? 0. Okay? Then this is 2e minus 2e, 0. 0 by 0. Okay, so use the rule once again. Minus pi, derivative of sin is cos 2 pi x divided by 4e raised to 2x minus derivative constant is 0. Loudly.
Differentiation of e 0.
E constant, na? So derivative constant is 0. So substitute x equal to half. So minus pi cos of x equal to half. 2 will cancel. Cos of pi into 2 pi divided by 4e. Yes, so it is minus pi. Cos of pi is minus 1 into 2 pi divided by 4e. So pi square divided by 2. 2 will cancel. Minus minus and will cancel. Pi square divided by 2e. Getting everyone?
2 or 2 to x after that. Third last step नहीं समझा.
Third last step.
इसके बाद बताओ.
This one. अरे x equal to half ना? Right, 2 will cancel. E will only remain. Yes. Next example. Third example. Any doubt, team? Is there any doubt?
No, sir.
Okay, let me continue. Limit. I am expecting answer of this question from you. Huh? So, limit x tends to 0 cot x minus 1 upon x divided by x. Cot x minus 1 upon x divided by x. Solve fast. Do it yourself. So we can convert cot x into tan x or sin x cos x. One of them. Convert cot x into tan x or sin x cos x. One of them. So do it yourself. I will also solve it. It's always better to solve it yourself once you understand the concept. So first we'll simplify, then we'll substitute x. Cot is cos x divided by sin x minus 1 upon x divided by x. So limit x tends to 0 x cos x minus sin x divided by x square sin x. Hope you might have understood this simplification. Okay. Then, as usual, we have to remove the sin x from denominator, multiply and divide by x. So we have x cos x minus sin x divided by x cube. Substitute x equal to 0. X equal to 0, 0. Sine of 0, 0. So numerator we have 0. Denominator also we have 0. So use it. Use the rule. So limit x tends to 0 Derivative, huh? So I will use the product. Derivative of x is 1, cos x as it is, plus x as it is, derivative of cos x is minus of sin x. Minus of derivative of sin x is cos x. Divided by derivative of the denominator 3x square. But I can cancel plus cos x minus cos x. So limit x tends to 0 minus x sin x divided by 3x. Again I can cancel 1x. So limit x tends to 0 minus of sin x. What is sin x by x? 1. What the answer is 1/3. Getting everyone? Understood? Next example. Clear? Now, just 1 minute. Now, x minus 10x, x minus 1, 6, 12, x, x equal to 0 by 0. Minus 2 sec x. Sec x is equal to sec x tan. 6x. Ix cancel. 6x. बरोबर का? आप इधर बंद है, sec 0 बंद है, minus 2 by 6. ठीक है ना? चलो next. Hope everyone is getting the answer. Okay. Before we continue, let me write few formulas and then we'll solve example on these formulas. So let me write the formulas. Hope you might have written the answer. Final answer written? Yes, right. Few formulas required. Yes, it is like this. First formula, right? Formulas. Log of b to the base a. Yes, how we can simplify this? Log of b to the base a. Yes. Log of b divided by log of a. 1. Second, suppose I have log of sec x or say sec theta, and I want to convert this into cos theta. How we can convert this into cos theta? This is equal to log of sec theta is 1 upon cos theta, right? And what is log a by b? Log a minus log b. Let me use that. Okay, so it is log of 1 minus log of cos theta. Right? Log of 1 is 0. So what is remaining? Log of cos theta. Okay? Write this properties. Write that. Formula number 3. Are they equal? Formula number 3. Limit of f of x whole square as x tends to a. Is it equal to limit of f of x, or somewhere one term is remaining? One term is in fact remaining. What is that? Should we write 2 here? Should we write 2 here? Yes? Should we write 2 here? No. What should be done? So whether we find limit of f of x square or whether we find limit of f of x and then we will answer. Understood? Write the third one. We'll use these 3 formulas to solve the next example. Yes. So write fourth example. Return the formulas. Write next example. Question is same. Evaluate the limit. Okay, so no need to write question again. Write the problem. Limit x tends to 0. Log of cos x to the base is sec x by 2. Base is sec x by 2. Okay. Divided by log of cos x by 2. To the base, understand what the base is? Base is sec x. So it should be like this. Limit x tends to 0, which is better. In numerator, we have log of cos x to the base sec x by 2, and in denominator, we have log of cos x by 2 to the base sec x. Okay, so solution. Let n equal to this limit. Okay, now I use the first formula, log of b to the base a. Log b by a. Let me use that one. So, limit x tends to 0. Numerator will be like this. Log of cos x divided by log of sec x by 2. Okay. Whole divided by, this is numerator. Denominator, log of cos x by 2. Right? Divided by log of sec x. Hope everything is very good. First formula I used. Okay. Now I will simplify this. Right? Limit x tends to 0. I am writing the terms in numerator. Log of cos x divided by log of sec x by 2 into reciprocal of the terms in denominator. So log of sec x divided by log of cos x by 2. We have this thing. And use the second formula. Right? Log sec theta equal to minus of log of cos theta. Sec converted into cos. So limit x tends to 0. No change in the cos x term. And this term will change. Minus of log of sec x term into. Now numerator will change. Minus of log of cos x divided by log of no change cos of x. Then this minus sign will cancel. Okay, and then we have limit x tends to 0 log of cos x divided by log of cos x by 2 whole square. Log cos term is 2 times 1, 2. Log cos x by 2 term is 2 times. So square of that. Now use the last formula. Okay, so it will be like this. Limit x tends to 0 log of cos x divided by log of cos of x term whole square. Okay, so it will be sufficient to find derivative of limit of this one, and then square and then okay. Clear up to this step? Now substitute x equal to 0. What is cos of 0? 1. And what is log of 1? 0. Again cos of 0 is 1. Log of 1 is 0. So we have 0 by 0 form. Right? 0 by 0 form. So use it. So 1 upon cos x derivative, 1 upon cos x derivative of cos x is minus 1 upon cos x by 2 into derivative is minus sin x by 2 and again derivative of x by 2 1 upon whole square. Ready na? Minus minus sign will cancel. Minus minus sign will cancel. Sin by cos is tan x. Sin x by 2 divided by cos x, tan x. And what about this 1 upon 2? 2 into 1. 2 tan x divided by tan x. Getting any of that? Now we can use the standard formula of tan x, or you can use the Taylor's principle. You decide that. Okay, let me use the standard formula. Tan x divided by x. Since I am dividing by x, I have to multiply by x. Numerator is divided by x multiplied by x. Same thing in denominator. Tan x by 2 divided by x by 2 multiply by x by 2. Next, again x raised to 0 see, this is equal to 1, this is equal to 1. So what is remaining in numerator? 2x. What is remaining in denominator? X by 2. Again x by 2 will cancel and 2 will be in numerator. Understood. Let's do the example. Okay. Next.
So, if it that means
Minus again the possibility.
minus number was but minus sign cancel पण होगा
Put just paper with it. Next. Return the final answer 16. Now before we proceed to the next example, we are writing few formulas. Okay. Return final answer. Okay. Now see towards board and understand. At the end we'll write the formula. So suppose I have x raised to n. Take note is derivative of x raised to n. And x raised to n. Right now. Right. I am using the same formula. So I am writing few formulas of derivative. Take note is d by dx of x raised to a, where a is a constant. What is the derivative? A x raised to a minus 1. Okay. In the same way, take note is d by dx of a raised to x, derivative of a raised to x.
divided by log x.
Correct. A raised to x.
Log of x.
Just 1 minute. Derivative of a raised to x. Exponential term na. So a raised to x into log of a. Okay. Now we want the derivative of x raised to x. What is derivative of x raised to x? Like this. Make y equal to x raised to x. Then take log on both sides. Log y equal to x log x. Okay. Now differentiate on both sides. Okay. So that is differentiating. Okay. So the derivative is 1 upon y dy by dx equal to, we have to use the product rule. X as it is, derivative of log x is 1 upon x plus log x as it is, derivative of x is 1. Okay. Then next is dy by dx equal to y. Okay. This x by x is 1 plus log x. Now let me substitute the value of y. Y is here. Y is x raised to x. Na? So d by dx of y, that is d by dx of x raised to x. What is that? Y x raised to x 1 plus log of x. Log of x. Getting anyone? Last. Then what is in the same way? What is d by dx of a raised to a? A raised to a into 1 plus like this, na? A raised to a 1 plus log a. Isn't it? Correct or not? Correct or not? How it is correct? What is a? A is variable or constant? 5 raised to 5. What is derivative of 5 raised to 5? Constant, na? What is derivative of constant?
0.
0.
0. That's it. A is constant. Therefore, we are differentiating with respect to x, na? If we differentiate with respect to a, then answer will be a raised to a 1 plus log a. Samajhte ki nahi? Right? Write these 4 coordinates. And then we'll solve one example depending on these 4 coordinates. Write the 4 coordinates first, write them.
असं आहे का?
Example. Those who completed, go to the example. Limit x tends to y. Right. Limit x tends to y, x raised to y minus y raised to x divided by x raised to x minus y raised to y. Solution. Solution. Yes, done. Let L equal to limit x tends to y, x raised to y minus y raised to x divided by x raised to x minus y raised to y. Tell me what is role of y here? What is y here? Y is a function of x or y is a variable. What is it? What the y is?
Constant.
Y is a constant. See, whenever we write limit like this, then limit of f of x as x tends to a. What the a is? Constant. Okay. So limit x tends to y. Therefore, y is a constant. Since below this mention this. Since limit x tends to y, therefore y is a constant. Y is a constant. Now substitute x equal to y. See what we are getting. X equal to y. Y raised to y minus y raised to y. What is y raised to y minus y raised to y? 0. See the denominator. y raised to y minus y raised to y. What is that? 0. Okay, 0 by 0 बोलता सरल use the rule and use the 4 formulas that we have. Okay, so it will be like this. Limit x tends to y and the derivatives. Derivative of x raised to y is constant. So y x raised to y minus 1 minus of, which is exponential function. So y raised to x log of y divided by derivative of x raised to x, formula number 3, no invariant. Okay, so x raised to x 1 plus log x minus, what is derivative of y raised to y? Constant term 0. Right? Whenever we are seeing y x raised to y, okay, that is substitute the limits. Substitute the limits after substituting it. So x equal to y. So y means y raised to y into x raised to y minus 1. That is y raised to y minus 1 minus y raised to y log of y divided by y raised to y 1 plus log. Okay. Now we can write like this. See, base is same, y raised to 1 and y raised to y minus 1. So add the powers 1 plus y minus 1. So y raised to y minus y raised to y log y divided by y raised to y 1 plus log. What we can take common from the numerator? Y raised to y. Denominator as it is. That's it. Here is the answer. Right answer. 1 minus log y divided by 1 plus log y. Okay, let me read the answer. Okay. Next. Let examples for homework. Homework. Right. Evaluate following limits. Right. Evaluate following limits. X e raised to x minus log of 1 plus x divided by x square. Answer is 3 by 2. Check your answer. Answer is 3 by 2. Limit x tends to 0 e raised to x. Sorry, e raised to x minus e raised to minus x divided by log of 1 plus x. I don't have answer on this. Third, limit x tends to 0. One simple example. 1 plus x raised to n minus 1 divided by x. Answer is n. Fourth, limit x tends to a. I think you can predict the answer of last one. Anyone who can predict the answer of last question? Correct. 1 minus, same as the previous question. 1 minus log A divided by 1 plus log B. Solve these 4 examples. Okay, next one, type number 2. Type number 2. Finding the values of the constant so that it will satisfy the given conditions. Finding values of the constant. Right? Finding values of the constant. Example number 1. Start with the first example. Right. A, first example. Limit x tends to 0 of sin 2x plus p. P is the parameter that we want to find. Sin x divided by x cube. P is fine. Sin 2x plus p sin x divided by x cube is fine. Just 1 minute.